disorder. Remy boys ain't over. Fast money don't slow, but no one can control.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Wulandari. I'm from Wulandari, from Malang State University. I'm from Faculty of Mathematics and Science, study program Physics Education 2018. This video is for complete the task of English for Physics taught by Mr. Nur Hidayat. Okay, in this video, I will want to explain about the Hall effect sensor. Hall effect sensors are decided that are activated by an external magnetic field. We know that magnetic fields have two important characteristics, flux densities and polarity. The output signal from the Hall effect sensor is a magnetic field density function around the device. When the magnetic flux density around the sensor exerts a certain predetermined result, the sensor detects and produces an output voltage called Hall voltage or VH. The principle of the Hall effect sensor. The Hall effect sensor basically consists of a thin piece of rectangular p-type semiconductor material, such as gallium arsenide, indium antimonide, or indium arsenide, passing through a continuous current dome itself. When the device is placed in a magnetic field, the magnetic flux line exerts force on the semiconductor material, which deflects the carrier charge, electron and holes to one side of the semiconductor plate. The movement of the charge carrier is the result of the magnetic force they experience passing through the semiconductor material. When this electron and holes move to the other side, potential differences are produced between the two sides of the semiconductor material by this charge build-up. Then, the movement of electron, the semiconductor material, is influenced by the presence of an external magnetic field at a right angle, and this effect is greater in a flat rectangular material. The effect of generating a voltage that can be measured using a magnetic field is called the Hall effect. After Edwin Hall rediscovered it in 1870 with the basic physical principle underlying the Hall effect to be the Lorentz style. To produce potential difference across the device, the magnetic flux line must be perpendicular to the current flow and be the correct polarity, generally the south pole. Hall effect provides information about the type of magnetic poles and the magnitude of the magnetic field. For example, the south pole will cause the device to produce a voltage output, while the north pole will have no effect. In general, Hall effect sensor and switcher are designed to be off or open circuit condition when there are not magnetic field. They only active on or closed circuit condition when expiring a magnetic field with surface strength and polarity. Hall effect sensors are available with linear or digital output. The output signal for a linear sensor or analog is taken directly from the output of the operational amplifier, with an output voltage that is directly proportional to the magnetic field that passes through the Hall sensor. affect linear voltage. Linear or analog sensor give a continuous voltage output that increases with a strong magnetic field and decreases with a weak magnetic field. In linear output Hall effect sensor, as the strength of the magnetic field increases, the output signal from the amplifier will also increase until it begins to saturate by the limit imposed on it by the power supply. Any addition, increase in the magnetic field will have no effect on the output but drive it more into saturation. Digital output sensor, on the other hand, have a thin striker with built-in hysteresis connected to the arm end. With the magnetic flux passing through the whole sensor exerts a preset value, the output from the device switches quickly between its off condition to an on condition without any type of contact bonds. This built-in hysteresis eliminates any oscillation of the output signal as the sensor moves in and out of the magnetic field. Then, digital output sensor has just two states, on and off. There are two basic types of digital Hall effect sensor, bipolar and unibipolar. Bipolar sensors require a positive magnetic field or south pole to operate them, and negative field or north pole to release them, while unibipolar sensors require only a single magnetic south pole to both operate and release them as they move in and out of the magnetic field. Hall effect sensor can be used in electronic switches that have several advantages, including the first, it is relatively cheaper compared to the mechanical switches and more reliable. Second, can operate up to 100 kHz. Third, not affected by environmental conditions because the sensor is in a closed package, so that it can be used in a less friendly environment. Fourth, can detect a wide range of magnetic field. 5. Can detect the north pole and the south pole. The last is flat shape, so that it can be used on thinner electronic device. But this Hall effect sensor also has weakness, namely the level of measurement accuracy that is lower when compared to similar sensors such as a magnetometer or a sensor based of magnetoresistance. So this is the end of my video. I hope it can be useful for you, and I'm sorry if I have a mistake. Thank you for watching, and wassalamualaikum warahmatullahi wabarakatuh.